In our do now, we're asked to solve each of the quadratic equations by completing this square. So first thing in 2x squared plus 8x plus 4 that I want to realize is that there is a common factor of 2, that all of these terms are divisible by 2. So we're going to divide both sides by 2. So we have x squared plus 4x plus 2 equals 0, which is not a perfect square trinomial because this c term is not a perfect square. We're going to make it a perfect square. So we're first going to move our constant term to the right side. So we have x squared plus 4x equals negative 2. Now we're going to add b over 2 squared. So b is 4, 4 over 2 squared, 4 over 2 is 2, 2 squared is 4. So we'll add 4 to both sides. When we do that, now we have x squared plus 4x plus 4, which is a perfect square trinomial, equal to positive 2. 4x plus 4 can be factored to x plus 2 squared. X plus 2 times x plus 2 would give us x squared plus 4x plus 4. Now, because it's a perfect square, we've got that exponent of 2. We can just take the square root of both sides. So x plus 2 is going to equal to plus or minus the square root of 2. 2 is not a perfect square. There are no perfect square factors of 2. So the square root of 2 is fully simplified. All we're going to do is subtract 2 from both sides to get x is equal to negative 2 plus or minus the square root of 2. So we have 2 irrational roots. Number 2, v squared minus 3v minus 28. No common factor to divide out. Not a perfect square trinomial, so our first step is going to be to add 28 to both sides to move that constant term over. So we have v squared minus 3v equals 28. Now here a little more complicated because it's an odd b value. We're going to do negative 3 over 2 squared, which would give us a positive 9 over 4. So we're going to add 9 over 4 to both sides. That'll give us v squared minus 3v plus 9 over 4. Now here's where I would go to my calculator if I don't want to spend time doing all of those fraction operations, to do 28 plus 9 over 4 to get 121 over 4. And remember, we want to leave this as an improper. It's going to be easier to work with. V squared minus 3v plus 9 over 4 is a perfect square trinomial. Okay, if we look back to the pattern recognition we did yesterday, that's going to factor into v minus 3 over 2. We're going to have half that b value in there as the number, equals 121 over 4. Now we can take the square root of both sides. So we get v minus 3 over 2. 121 is a perfect square, so is 4. Square root of 121 is 11. Square root of 4 is 2. So this is going to be plus or minus 11 over 2. So because we can combine like terms, we can simplify. We're going to split into those two cases. V minus 3 over 2 equals positive 11 over 2. And v minus 3 over 2 equals negative 11 over 2. So we'll solve each equation, which will give us a positive 7 and a positive 4. So we've got our solution set of 4 and 7. Okay? So what we're going to do first today is we are going to take the general standard form of a parabola of a quadratic and solve for x by completing the square. This is not something you are going to be asked to replicate. It's just part of a how and why. I want to show you where we get a really cool formula called the quadratic formula that we can use for all quadratics. And this is where it comes from. First thing we're going to do is take our ax squared plus bx plus c and set it equal to 0. Now, everything we've done completing the square with has had a leading coefficient of 1. Right now, there's not a leading coefficient of 1. There's a leading coefficient of a. So we're going to divide both sides by a. So that's going to give us x squared plus b over ax plus c over a equals 0, because 0 divided by a is just 0. Now we'll move our constant term, c over a. So we have x squared plus b over ax equals negative c over a. Our next step is to add the b over 2 squared. So that's going to be b over 2a squared, because that b term is getting divided by 2. B over 2a squared is going to give us b squared over 4a. Okay. So now we're going to add b squared over 4a to both sides, giving us x squared plus b over ax plus b, this should be a squared. B squared over 4a squared equals negative c over a plus b squared over 4a squared. Okay. To finish completing the square, we need to get this left side to one term. So to do that, we need a common denominator. Okay. The common denominator would be 4a squared. To get this to be 4a squared, what I'm going to do is multiply both sides, both the top and the bottom, by 4a. When we do that, we get negative 4ac over 4a squared plus b squared over 4a squared. Now these are like terms, we can combine them. And when we do that, we reorder, making this b squared minus 4ac over 4a squared. So that gives us x squared plus b over ax plus b squared over 4a squared equals b squared minus 4ac over 4a squared. Okay, so now we factor the left side, right? If we remember from our pattern recognition, right, our number in our factored form is going to be half the b term, or you can think of it as the square root of the c term. Either way, that's going to give us b over 2a. So we're going to have x plus b over 2a squared equals b squared minus 4ac over 4a squared. So just like we always do, we're going to take the square root of both sides, which gives us x plus b over 2a equals plus or minus the square root of b squared minus 4ac. Now, b squared minus 4ac, a binomial in the numerator, we can't simplify that. But the denominator, 4a squared, is a perfect square. That we can simplify, right? The square root of 4 is 2, and the square root of a squared is just a. Okay. Now, from here, we're just going to solve for x by doing minus b over 2a minus b over 2a, right, which gives us negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. Notice these are like terms, so we can write them as one. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. And there you have it. That is what we call our quadratic formula. Now we can use this quadratic formula to solve our quadratics just by knowing the a value, the b value, and the c value. This is a formula you'll be given on the Regents exam, so you don't even have to memorize it. You can just plug it in. But there is a fun way to memorize it. It goes to the tune of Pop Goes the Weasel. You just say x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So there's an easy way to remember it. Okay. So if we take a quadratic, we know how to factor, right? We know what factors of negative 10 add to negative 3. Well, that would be negative 5 and positive 2, right? We know that's going to give us the zeros of positive 5 and negative 2. Okay? We can get that same result by using the quadratic formula. We just have to identify our a value, our b value, and our c value. So our a would be 1, b is negative 3, and c is negative 10. So now we just substitute in. X equals negative b, so negative negative 3, which is going to give you a positive 3, plus or minus the square root of b squared, remember we're using parentheses, minus 4 times a times c, all over 2 times a. And now we're just simplifying. Right, so that means we're going to simplify inside the radical because that works as a grouping symbol. Negative 3 squared is positive 9. Negative 4 times positive 1 times negative 10 is going to give us a positive 40. Right? I don't recommend putting this all into your calculator. Your calculator does PEMDAS wrong often. Okay? Over 2, which gives us 3 plus or minus the square root of 49 over 2. We want to notice that 49 is a perfect square. Its square root is 7. So we get 3 plus or minus 7 over 2, which means we're going to break it into those two cases if we're adding 7 or if we're subtracting 7. Okay, which should give us 10 over 2 or 5 and negative 4 over 2, which will give us negative 2, the same roots we saw when we factored it. Okay, so let's do a couple more and see how it goes. Okay. So our next example, our leading coefficient is greater than 1, no big deal. So 2x squared plus 5x plus 3, this is something we couldn't have factored any other way. Leading coefficient is greater than 1. This is a perfect candidate for the quadratic formula. So a equals 2, b equals 5, c equals 3. Oops. So now x equals negative b plus or minus the square root of b squared minus 4 ac all over 2a. So again, we're just simplifying, right? 5 squared is 25. Negative 4 times 2 times 3, that's going to be negative 8 times 3, so negative 24 all over 4. 2 times 2 is 4. So that'll give us negative 5 plus or minus the square root of 1 over 4. Remember, 1's a perfect square, so that's going to be negative 5 plus or minus 1. The square root of 1 is 1, all over 4. So we're going to split into our two cases, negative 5 plus 1 over 4, which will give us negative 4 over 4, or negative 1, or negative 5 minus 1 over 4, which gives us negative 6 over 4, which simplifies to negative 3 over 2. So we've got our solution set of negative 3 over 2 and negative 1. A little different because our quadratic's not in standard form. So the first thing we want to do is get that quadratic into standard form and equal to 0. So that's going to be subtracting 2x squared and adding 6x. Once we do get it into standard form, that's going to be what we're looking at for our a value, our b value, and our c value. So a is going to be 2, b will be 6, and c will be 1. Now we're just going to substitute in x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So in that simplifying, right, 6 squared is 36 minus 8 over 4. 36 minus 8 is 28. So we've got the square root of 28. We want to notice that square root of 28 can be simplified. So square root of 28, we want to break down into a product of perfect squares. The largest perfect square factor of 28 is 4. So that can be square root of 4 times square root of 7. Square root of 4 is 2. So that's going to be 2 rad 7. So as we simplify, we're no longer going to use square root of 28. We're going to use 2 rad 7. So we're going to say x equals negative 6 plus or minus 2 rad 7 over 4. Now that's something we can reduce, right? Each is divisible by 2. So we're going to divide both by 2 to get negative 3 plus or minus square root of 7 over 2. Because negative 3 and square root of 7 aren't like terms, those can't be combined, we can just leave it as negative 3 plus or minus the square root of 7 over 2. Okay, if you want to write it out into the two cases, you can. Okay, and on to number 3. So on number 3, we've got 4x squared minus 8 equals x. Again, we're going to have to take that and put it into standard form, which gives us 4x squared minus x minus 8 equals 0. So a is 4, b is negative 1, c is negative 8. X equals negative negative 1, so a positive 1, plus or minus the square root of b squared minus 4ac. Okay. All over 2a. So that's going to give us x equals 1 plus or minus the square root. Negative 1 squared is 1. 4 times 8 is, let's see, 128. Negative times negative is a positive, so it's going to be plus 128 over 8. X equals 1 plus or minus the square root of 129 over 8. Thinking about simplifying the square root of 129, 129 is not a perfect square, and there aren't any perfect square factors of 129. So that's as simple as it can be, and we're just going to leave our answer just like that.